So I'm the CTO at Angel. So previously I used to do I used to sell groceries. Now I sell stocks. So the scale that we operate in varies from 300K requests per second, it spikes to million above. And the apps have about 10 million daily active users. Right? So I have specialized unintentionally in changing engines during the flight. So while the business is growing, you have tech debt, things not working, and business wants to add new features, and I'm pushing back. That's been the story for 5 to 8 years now. So I also did a startup in between, Go Ibibo. I met some of you guys there. So that was also very interesting. So I code still in primarily in Python and Go, and that's actually what keeps life enjoyable. So actually, the topic about what I'm going to talk about is Angel One quickly, Redis, how we use it, and 2 recipes for Redis. And primarily, the question that I'm going to ask you all is, what is the most important feature you need in a product? Any guesses? Sorry? Speed? Anything else? Reliability, absolutely. So, right? So it doesn't matter how fast it works if it's not reliable, right? So reliability is the number one feature I'm going to talk about, and how we are trying to achieve it with 2 recipes with Redis. So about Angel One, so it's a fintech company that we are. It's the largest listed retail broker in India. So we deal everything from mutual funds to stocks to gold, peer-to-peer lending. We have about 10 million app downloads. If you see the business, right, this is in the last year or so, we've grown 3 times. Right? So number of orders, number of people on the platforms is just exponentially growing. We are adding more people in a month. I just met a ex employee. We're adding more people in a month today than what we had as an entire code user base about 2 years back. So that's the level of growth that people are coming onto this platform, right? Many younger folks in remote parts of India, they don't want to put their wealth in a bank, right? They want alpha. They want to generate more returns on their investments, and so they're turning on to platform like ours. Also want to point out that, this is what my CHRO told me to make sure I talk about. We are one of the listed as a great place to work for 6 consecutive years. I don't want to disappoint him. So this is some stuff from our app. So for people who are not very familiar, right? So this is what real time means for us. So we have about 10,000 data points in a second coming to us about things like prices, how many people are selling at what price, how many people are buying. And we just have to pipe those into 10 million devices. It's a simple problem. And, and the fact is, if you are a second late, it's of no use, right? Because people want to take real-time decisions, right? 9:15, everybody is waiting to make their $1 billion, and they want the information and they want to place their trades. Similarly for charts, people are very picky about charts. They want to see last 1 week, last 1 year, 5 years, whatever. And they want instant results. Nobody wants, so you can't do a group buy and aggregates, all that stuff, right? It's out of the question. So I'll talk about how we use Redis in 2 different places to achieve this. So this is our scale. This is a real screenshot during a very relaxed period for us, December, New Year. So as you can see from 9:15, the traffic goes from near 0 to more than million, right? So, and this grows exponentially during things like expiries, where people, the bets are squared off and things like that. So this is near 31st December. So while most people are spending their New Year's partying, our SRE team is making sure that nothing goes wrong. Another thing, I want to be realistic about our response times. Most response time, as people have said, right, are sub-milliseconds. But there are non-linearities where sometimes things spike out. And my job and my team's job is to make sure that these mountains never rise, right? And That's a constant endeavor on our side as we add new features. Quickly on the tech stack, I won't get into too much detail, but we have two parallel things. We have a low latency real-time stack. This is in a private data center. So this has to be handcrafted for latency. Right? You can't have any variability here. So the network, everything is handcrafted to make sure, and we have a lease line to the exchange. Right? So there's not even an internet provider that we rely on. So this is what you get the real-time prices, data, the order placement and things like that. And we have a big footprint in the cloud, which gives you things like recommendations, fraud detections and things like that. Something which can happen not so real-time, but as a fast follower. Right? So we code primarily, the most of the code is in Go, both sides. And we use Redis in both sides as, and very differently. We use Redis very differently on both sides. One more thing that is very important for us as a regulated business is business continuity. So if God forbid an earthquake hits Mumbai, people still want to trade. They want to buy Reliance or sell Kotak or whatever they want to do, right? So we have 4 data centers in India spread across. And we have data sync between peers so that if something goes down, we can quickly fail over to another shard. And though data replication is something that most people tout, getting it right is extremely difficult, right? And because you don't want to lose data. Most people say, I don't want to lose data, right? But you can't do a globally distributed transaction. So there is some nuance to how do we achieve this. By the way, just on previous slide, this is something, just to assure most of you guys, our authorities here like SEBI are very particular about this. So they have actually asked me once during real time to switch over during live traffic, just to prove that we can do this. So this, so things can be pretty intense during the workday. So there are 2 distinct use cases where we use Redis, and in the context of reliability. One is it's a cache, right? And it's enjoyable, as Peter mentioned. So we can try out all the different features, and we can very quickly iterate and see what value we can add, what features we can build for customers using the toolbox that Redis provides. Examples are session stores. We also use a feature store, as Suyash mentioned, things like that, right? So the key characteristic here is it needs to be fast. It's okay to miss some samples, right? For example, if your session store goes away, the worst thing is that some people can get logged out. Right? That's the worst thing that can happen. But we also use it as a DB, as a very fast DB, right? And the thing that here is data loss hurts. And the key to achieve reliability is to understand that bad news will happen. It's not a question of if something bad will happen. The question is, what do you do when something bad happens? Right? And actually, it's very interesting. We worked with Redis Enterprise to make sure that we have very well-defined SLAs, so we don't lose data. And how do we get back to a normal, to full consistency within a very guaranteed amount of time is something that we have worked on. So there are 2 different recipes that I'm going to talk about. So this is the cache recipe. So we use open source Redis in a pair. We use keep alive D, and we use something called as we use keep alive D, and we use something called as VRPP. So it's the same IP address. If one instance fails over, the clients don't need to change their connection strings or whatever. Question is this highly available? Any answers? Yes, no, maybe? So, well, the main thing to note here is the replication is asynchronous, right? So you can, for example, if a bank does this and you say add $1 million, right, it will say okay, and it will take some time before it reaches the replica, right? And if something happens here, then the write is lost. Any way I can control this? So Redis just gives you a command. It says wait till all the replicas essentially have the write before you reply and tell your client that the $1 million is in the bank. Right? Anyone see anything wrong with this? Sorry? Latency is of course one there. Latency is there. The question is this reliable? Given the context that bad news will happen, things will go down. Okay, one thing is durability. Anything else? So the question of durability, right? So if you do this, your write will be on both places. Maybe not on the disk, but at least in the memory and two different machines. The problem is it's not really HA because you need both the machines to be available for your writes to succeed. So what you originally solved to, what you wanted to solve was that if a machine goes down, my data is secure. Whereas now what happens is if your machine goes down, your write doesn't work at all. Right? So we have compromised availability for consistency. Now this may be good for you, this may not be the right fit for you. But the key point is you need to understand your use case to make such choices. Right? So this is something, if you guys are more interested, there's a big chat with Salvatore on this. Very interesting lens of detail of how this can go wrong and how this can be used. So what do we do, right? Just to recap on what we want in the reliable part of the stack. Data loss hurts, and we want atomicity and isolation. So if multiple people are doing something on the similar set of data, we want to make guarantees of what will happen. Either something or it's like eventuality A or B, not something in between, right? And this is where we worked very closely with Redis Enterprise to make this recipe happen. Just a quick cap on what a cluster is. I'm sure most of you know this. But essentially, with a cluster, your keys are distributed over a set of nodes. Right? So rather than the pair that you saw, which is just very specific, here it's very multi-tenant, and the sharding and everything allows you to have your keys distributed among the nodes. So one node going down, you still have your data on someone else. The reader election is very similar to Raft, if you guys are familiar with the protocol. So people advertise themselves as leaders, and if people actively try to become leaders. And replication is asynchronous but can be tuned. That said, and this is open source Redis. I'm still on open source Redis cluster. So there are some complexities here, like the clients have to handle sometimes complicated states. So if your topology changes, if a node goes down, data has suddenly available from instead of this machine on this machine. And now your client needs to understand that. It needs to handle states like mood, which can get complicated. Also, things which we are used to in a single machine, like cross slot, or if you do mget or things like that, those will start to fail. And your QA team will not catch those queries, right? So things creep up on you very, very, very slowly. And then you can get into very other sorts of failures. Like if your leader if there's a network partition here, right? There'll be some time before this node realizes that it's not a leader. It's not supposed to accept writes, but it's going to accept your $1 million. And then at some point, the client is going to say, oh no, I don't have the right, and it's going to erase it. Right? So there are complexities here. Where Redis Enterprise helps us is that it moves all the complexity into another solution that it offers called bunch of things, but most importantly, something called as a proxy. Right? So the clients remain dumb, and they just delegate all the complexity to a proxy. And the proxy handles all the things like topology changes, and even it does scatter gather if needed. Right? Key thing to note, right? Again, this is a big toolbox. The configuration options here are pretty complicated, right? So one of the things that we figured out, for example, is the watchdog profile. So this tells you how jittery your network is. And as I told you, we're in a private data center, and we went with a very nice option earlier. But what we realized is the jitter is something, at least at our use case, we wanted a little bit more relaxation. So we changed it to a cloud profile, which gives us much better characteristics as a cluster. Slightly different picture of what it offers you. So it's basically all nuts and bolts together. So you have the open source shards, then you've got a thin piece of the enterprise components on top, which offload the complexity from the clients. What we really like is the uptime, right? As I said, uptime is key for us. It's a single pane of monitoring and management. So you have a very good UI, and I have some screenshots at the end to understand what's happening within your system. Right? This is very important for monitoring and alerting here. There's automated failover, and also there's multi-zone availability and REC awareness. So as I said, we have 4 data centers, and things are spread across, and things can move from one place to another. This really helps us as we move stuff around. How we use it is again, so what we do in our clients essentially. So besides the enterprise Redis cluster, we have, let's say, a source of truth like a database or Kafka or something else. And whenever we do writes, we do dual writes, but we read from Redis, right? The question is, what happens if the write fails? This is what I'll cover in this next slide. But the key thing to note is that there's a feed from the source of truth to the cluster. So it's easy to think of this, let's say, with Kafka, if you're familiar, right? So you have messages coming about the writes. So these are like multiple writes which have happened. And let's say you have lost certain writes for whatever reasons, right? The cluster, the whole system catches up on its own because the writes are idempotent, right? So that what idempotent writes basically mean that if you do the same write 10 times, it's not going to change the state of the system. So this allows us to still do fast reads, but we know that they are going to be consistent eventually. So worst case, if something bad happens and you see what are the orders that you have placed, it's possible that initially you may not see one thing if there's a outage or something goes down. Very soon it will catch up, and now you will be able to see everything that you need. And this is guaranteed within a time window, right? And this is so that we know, for example, within, let's say, 10 seconds, you'll be able to recover from the failure, and the writes will be back up. Another key thing on atomicity and isolation, right, is how do we ensure that if you're mutating multiple keys, that the state is sane, right? So we use, this is the Go client. The key thing to note is, and many people actually write code like this when you are moving fast without realizing what you're doing. The key thing to do is package all the mutations in a wrapper so that it's atomic. Either it happens as a whole or doesn't happen. This leverages Redis's multi-exec. But there's another feature that we need for ISO, like we need to ensure that if we modify a key and someone else has done it, we don't want to change, we want to revert the transaction, if you will. Right? So we don't want to change something which in middle half-baked state. And this is where I think Redis Watch, and Redis Watch has some features on the enterprise side which are slightly more useful for us. What Watch does is if any of the keys have changed, the whole thing fails, and so you can retry. Right? So this allows us, to have the consistency in a fast data store. Right? So we don't need to again go to some disk-based solution again. So Watch is available, but with the enterprise version, we have tunables which can guarantee stuff which we like. So this is still available. So what I've realized in my own dev work is many people don't realize this. So I wanted to make a complete picture, right? So if you want to do things like this, decrement and increment, you need both. You need atomicity, and you also need some sort of optimistic log to say either it happens or doesn't happen if the state has changed. So key lessons from our partnership with Enterprise Redis: know your use case, understand exactly what your customers want in a particular use case. Many times it will be just availability. So for example, if you are looking at recommendations or offers, right? People don't care if an offer does not get shown. People care if you show a spinner on your app. Right? Many times people care about consistency. Don't show them zero bank balance. You'll get a lot of calls, right? So there it's okay to show a spinner for a small time and give good data. So use cases vary. Know your use case. Understand the guarantees of your configuration. Right? Whatever you use, it's unlikely that the out-of-box config solves your use case. So understand what it means. Tune for the worst case and monitor everything. Right? So monitor everything means literally we use the enterprise Redis Enterprise monitoring systems, but we have also been we instrument all things like disk IOPS, CPU utilization on pretty much everything, so that we have clear understanding of what's happening. One thing I want to call out here is the support part. Right? We have a very active engagement with Redis Enterprise on support, and whenever there's an incident call in our stuff, it's pretty intense, as you guys can imagine, because every even if there's a feature down, people are complaining about losing money. Right? So everyone is on the call, and we have got and then the last few times that this has happened, we've got people come onto the call and give very actionable, quick insights about what's happening, right? And what we can do to salvage the situation on that day, and what we can do to avoid the situation going further. Right? For example, some of the things that happened recently is, so as you work with Redis and people start coding at a very fast pace, some of your queries may be suboptimal, right? And it's unlikely you'll discover that at lower scale. As your scale grows, right, your keys might get fat or things like that, right? So we have something called a slow log. Again, it's available in the open source version, but in Redis Enterprise, right in your face. It's probably the third tab as you open the pane. Right? So it forces you to look at what's slow in your system. Similarly, you can set alerts on things like, if your data set has reached a certain percentage of what's available, then how do you alert? These are some of the things we monitor, like IOPS, number of keys, read latencies, and stuff like that. So these are our eyes and ears. Without this, you can't go blind into building a very reliable systems.